Great. Okay, so just turned off my headphone speaker, so I don't hear people in the Zoom if they ask me a question. So be patient. In a moment, I'm explaining you how we are going to manage the course from now on. Okay. So today we are going to some organizational stuff, as I said. So how we go with the hybrid classes. Then I'm talking about the presentations that you need to make. So today I'm going to publish the list of topics and you're going to select them. And yeah, according to the timeline that we have in mind, you could start your presentations. Then we finished the notebook that we started last time. So the rest of pandas. And then I have a set of slides about the exploratory data analysis, or EDAs. They are based on chapter 3 of the book. And at the end, we are talking about visualization more deeply. I'm going to introduce you to Matplotly. Most probably we are not going to end it today, but I think if you can just start in the beginning, you can go with the rest of it yourself in the home. And then if we got some time left, we are going to introduce you to Plotly Express. Okay, let's start with the hybrid classes. So what we are going to do, first of all, I try to focus more in the class. So that's why I expect more of you guys to be here. Today we have only 10, 2, yeah, even less. So yeah, that's why I try to convince you guys to be more in the class. And in the Zoom, there are like still 15 or less than 20 people. So in like half of the class are not present now. And this is not very good. Yeah. If you have any comments how we could improve it, yeah, you're more than welcome to share them with me. But yeah, I think it would be a better experience for all of us if we could, yeah, you could be present here. Okay, and then for the Zoom, so from now on, I won't actively listen to the Zoom questions. What we are doing, so people who have questions in Zoom, they can write their question in a chat box, or they can just raise their hands. And like each 10 minutes or something, I will check if there is a question, and then they can unmute themselves and talk, okay? And we are also going to buy a technology that Professor Warren will just explain to me. So we will buy like kind of speaker that you can put it here. And if any of you start talking, it will automatically like direct to you, and it will be like it would be okay for everyone in the Zoom that can hear you, and you can also hear the people in the Zoom if they start talking, okay? But yeah, but for today we don't have it yet. But yeah, so for people in the Zoom, now I don't hear them. I will just unmute them from time to time to have all the questions. Okay, and yeah.
I think there is a strong reason for everybody to be here if we start basically discussing in the class and basically talking to the neighbor. It becomes important in order to take something away. Will this happen? Because until now it is more or less a lecture. Yeah. And I think for a lecture it is quite rational to stay at home and watch it on Zoom.
That's also a good question. So, I should think of how we can make it more interactive. Yeah, but for sure, when you start with the presentations, there would be more Q&As in the class. That's part of it, but yeah, I really don't know how we can make it more interactive at the moment.
I think one thing should be clear.
Yeah.
Once we have guest speakers, yeah, they come here in order to support this class. And therefore, big presence with guest speakers is important. Just
yeah. Yeah, for the guest speakers, I hope I can see the class field already. So yeah. Okay, so any questions regarding the Orga stuff? Let me see if people in Zoom have any question. Not yet. Great. Okay. regarding your presentations, so I won't put them on Doodle, so I will post it on the, let me, so first of all, let me share my screen. Okay, and so what we changed in our course homepage. So now everything is uploaded in YouTube. Hopefully all of you are okay with that. I tried to remove those part that you have. So in the beginning that you have open your cameras and everyone is on the scene. So I removed those parts and try to put everything in the YouTube. And then there's also one other link here. It's not still a link. I'm going to put the link there. So this is a list of presentations that you are going to make. Okay, these are the lists that I prepared already. It will be on a Google document that you can go there and just insert your emails and maybe your IDs, your student IDs, and then we can see the allocations of the topics. The thing, no, not necessarily. So just the email should be fine for me. But yeah, it's for free, so you can put the next columns whatever you want if you have a comment or something. The thing for the email is that some of these topics there is an asterisk next to them, and this means that you could do them in a team. Okay, so for example, talking about Git in the sixth topic. So talking about the Git is not necessarily possible to do everything in just 10 minutes. So, and I want to emphasize more on this topic. That's why I'm inviting you guys to work in a team and make a lengthier presentation. That's totally fine with me. But for the rest of the topics, I won't expect more than 10 or 15 minutes presentations. So yeah, so I hope you can see all the lists now, so you can at least see if you have any preference on the topics before I'm publishing them. So in the beginning, so for the next week, there is a Seaborn and Plotly. So there are two packages that could be very helpful for you if you want to visualize things. Then MLP Finance, which is a visualization specific for the financial data. It's not that much better than Plotly at the end, but yeah, if someone wants, it's good for all of you to hear about this. And then we talk about managing Conda environments, then Git and GitHub as an example of Git. Then regular expressions, markdowns. XLVins is it's a great tool that you can literally replace VBA with Python in the Excel. So you can just use Python for your Excel stuff. Then we focus on some geolocation things. So if you want to show a map, you just want to calculate some distances. There are things that hedge funds do. You're gonna need GeoPandas and Folio. We also cover some Unix shell commands because you are going to use them anyway. So I'm hoping the guy who wants to take over this topic is going to introduce it in the for Linux and Macs, but also some Windows commands that could be helpful. Then we have some legal stuff that we want to be covered. It's good for you to know them. Then we talk about parallelization and multi-threading. So with multi-threading, Ponderal swiftly. Prophet is a Facebook library for predictions of time series. That's also a great thing. There are some auto EDA things. So the EDA that I'm discussing today, there is some package that you could just introduce your data and then they give you some early analysis on the data automatically.
Start, but only one topic.
Yeah, I will change it. Yeah, to 2. Actually, I need to remove this because there's like a list of things, and like suite base details, funder profiling. There are like just three like best EDA automatic EDA things that people are going to present themselves. But people can choose to work as a team of 4 people and do the whole thing. So up to them. So from 25th topic, so we are going to show, try to make your code more fancy. So IP widgets is like, so if you want to have a website, you can have like the buttons and so on in your Jupyter notebook. This is a great thing to know. Voila, Streamlit, they are tools to make a dashboard. So if you have a data, you can make a dashboard with them. Then I think this is the most difficult thing that needs some IT knowledge. I'm not sure if there is any volunteer for them. So basically, if you want to make a big application, so you can initiate your own server on the PC, and then you create a server with a website that works on the backend with Python. And this is like the backbone of everything. And then Flask, Django, and so on are depending on this knowledge. Okay, so if there was no guy wants to present them, it's fine, I guess. I can do it myself. And then very importantly, I want to talk about Amazon AWS and Google Cloud. Nowadays, yeah, codes are getting more sophisticated. Data sets are much bigger than a PC to handle everything. So it's good for you to know something about cloud computing. So for Google, in addition to Google Cloud, we have Firebase that you could make applications with them. Then I'm trying to cover some APIs. So Google Translate APIs, Google Map API, YouTube API. So basically assume that your code is going to ask something about YouTube. So if you want to, for example, get some analysis or statistics of YouTube videos, you could use the YouTube API and just collect them, everything. So we just had a paper with the YouTube API. So it was like the startups YouTube video, and then we got the analytics of them and then started to analyze them. So you could use this kind of data in your future career, or if you want to go to academia, all of them are going to be needed. Twitter API as well. So there are many people who try to get some tweet text and do some analysis on them. So it's good to know them. Also Facebook APIs. Then again, some legal stuff about GDPR and privacy. Then we go with some web scraping thing with Scrapy. Then I also hope someone is volunteer to discuss about Dockers. This is a very broad topic. Maybe even more than 2 people could do that. Then some other libraries for textual analysis that we will have at the end of the semester.
Can you give me the microphone?
Yeah.
I think maybe students will want to know how this is basically built up. I think your plan is to first come to certain places and online and everything is needed. But even then, well, it's technically possible to erase somebody else's name, yeah. But we see the history. It's
yeah.
So who is the first? Yeah, it must have been erased.
Yeah, exactly.
Second question is next week is very important. Most students will naturally prefer some topic.
There is a trade-off actually. Yeah.
Okay. I think this is
yeah, I try to select the most easiest stuff as well in the beginning. So
let us remember that next week.
Yeah, you can do it with Zoom. Yeah, you can do it with Zoom. Especially like the Seaborn and Plotly is on our next session. So they are starting in the class. So the first 3 topics could be recorded, but I prefer them live in the class. So because it's like part of our course, and then if someone is volunteer to this tree, at the end, I will be in contact with them with emails to make sure that everything is going to be covered properly and so on. So the thing is that for the first 3 guys who are volunteer here, I'm offering some supports. Okay. But after that, like if you look at these dates, they are all some weekends. So it's basically the Saturday of each week. And in the Saturday, you make your video, you post it on the Piazza page. So you basically give me the video, I upload it on the YouTube and make a Piazza post. Then students can come and discuss already. And in the Monday, we have the course, we will have another Q&A. So I will just overview the whole thing, and students have the chance to get engaged with the people who produced that video. Okay. One more.
It's always convenient to have everything on YouTube. Of course, there was no legal obligation to put anything like your face.
Yeah.
Want this? Send it to Zazen, and we will circulate it only.
Yeah, if you want.
But of course, we prefer to find on YouTube. It will not be searchable, as far as I know.
Is it? I don't think so.
We have a special channel.
We have a channel for that, but I'm not sure. So if I want to make it private, then all of you need a Gmail account too.
Even if it's on YouTube, I don't be surprised if the creators extend it.
Yeah, I think.
If you don't put your name in.
Yeah, if you won't become a politician, don't worry. So no idea. Yeah. Cool. Yeah. Let's see if people have questions on Zoom. Yeah. Okay. So do we have to appear in the class for the presentation, or if it's okay via Zoom? It's okay to be just on Zoom. Yeah, you can just present it. It's not a problem. But except for the first 3 topics, the other things are a recorded video. So you just needed to open your Zoom, record it for 10 minutes, and share the file with me. That's it. Are these topics assigned as a first come, first serve? Yes, it is. And so the number of group members is limited to 2. Yeah, I don't see any other topics more than 2 people. So yeah, maximum 2, but it's up to you. So usually if we have a 1 week deadline, so it means that you guys could collaborate with yourself on these topics. If you want, you could say, okay, I'm discussing more this and you that. Each week I will get in contact with those people who have the presentation at the end to just make sure that the collaboration works, at least in the beginning.
Just repeating it. So if we're here in person doing presentation, we don't have to record it to like a video.
No, the thing is, we don't have the time in the class to have all these presentations. There are 51 presentations. We won't make the time. So that's why I'm going to put the videos on the YouTube, and we just discuss like 2 or 3 minutes about each of them in the beginning of the next class.
So the first presentations will be recorded like we're recorded right now.
Yeah.
I'm recording it. Others are recorded.
Exactly. So you're just recording them and then share with the students. Yeah. There was a question.
When will the spreadsheet available online?
The spreadsheet would be available by the midnight. So yeah. Yeah, but there is like clever ways to do that. So yeah, if you're clever enough to spot the change automatically, yeah, you're welcome. So someone said hard to hear for so far, but we decide I think we handled it already. For many topics, should each person apply? How many? So there's just one. So I not more than 1 topic, please. So try to find the empty spot here and put your email and ID here. That's it. Not more than one. Okay, is the presentation supposed to be something like a Jupyter notebook that we explained in the video, or a general introduction to the libraries or what you can do with them? It usually depends, but it's mostly presentation kind of style. You're more than welcome to have a Jupyter notebook to show some applications, but I guess in 10 minutes, you won't have time to do that. 10 or 15 minutes is not enough to show some codes. But if you have prepared some codes, you're more than welcome to show it in the video or share your notes in the Piazza. It's up to you how you want to handle it. So did I understand correctly that the list will be uploaded at midnight? Yes. It could be like in the evening or whenever. So yeah, so I just don't want to set a specific time that benefits some people. So I just want to do it randomly. Everyone is worse off. Okay. Okay, where we can find a spreadsheet, that's a good question. So it will be here on the, oh no. On this red one. So this will be a link. It's not a link yet, but it will be a link. You can choose the often not listed in the YouTube.
It's the way to put things on YouTube only for the class and not for the general.
Okay. Okay, I will search for that. Okay.
Not want to be seen by the future employer.
Yeah, if you want, I don't know if it could. I think at the end it would be helpful for you to be on the YouTube, but yeah, if you don't want, just let me know. It's up to you. Any more questions?
Zafran, can you hear me?
And I think we don't have any raised hand. Okay, so we can continue. Okay. So I think we covered like all of these things here. Yeah, so there's just the Dropbox links that you can just upload your videos that I can get them, and then I will upload them on the YouTube later. Yes. No, I will do it. Yeah, it should be fair for everyone. So, but yeah.
I think we should film first. Please ask on Zoom.
Do we have any volunteers for the first 3? So could people in the Zoom just raise hand if they're volunteer? Okay, there is nothing. Okay, so you guys after the class just come to me and I will fill them. Oh, but there was another question, I guess. Will we receive a message on Piazza that the list is uploaded, or should we check this document with a hyperlink later? You should do it by yourself. So, but I will send a reminder tomorrow anyway in the Piazza. But I think that there shouldn't be a big difference in the topics. So it shouldn't be the case that one of them is very easy, the other is very difficult. For all of them, I'm sure that in YouTube there is already a 10-minute presentation of them. So there is no easy or difficult presentation topic here. Okay. Good. Okay. Okay, so before I'm starting with the EDA presentation, let's finish what we started last week. So just going to finish the merge. So I won't run them. I just want to go over them to be a bit faster. Okay, So previously we've worked with a data frame that contains 4 companies' stock returns from 2018, I guess, until 2020. And now we want to merge it with a new data set, which is a volatility index. So for volatility index, if you don't know it, I just go over it over Wikipedia. This is also called fear index or fear gauge. And it is basically an index calculated by the expected volatility of S&P 500 options, and it usually have a spike if there is a crisis going on or something. So, for example, in the it was like the Corona crisis, that was like the last Black Monday, that it was like going to a historic high. And so whenever there is a crisis in the market, this index is going up. And when everything is called.
This is the client volatility from S&P 500 options.
Yeah, that's. Exactly. So, okay, how we get this data on VIX? So there is a tool library, which is Yahoo Finance, and you can just install the Y Finance with PIP, and then import it as YF. So it's up to you if you want to have any other name as YF. So we basically say I want the YF to download this ticker, which is the ticker of VIX, from this start to this end. So it will be a daily VIX numbers, and it will be downloaded. And if you look at this, you can see that you have the VIX open, high, low, close, like a daily adjusted close for the date that you wanted. So from 2010 until 2019. Okay. And now, as you see, the index is date here. And in order to do the merge, we need to merge them based on the date. Okay, so we have the stock returns as date, and we have the VIX returns as date. So that's why we need to have date. We need to prepare the date column in a way that it's mergeable. Okay, so the first thing I do is I create a new variable, a new column. I call it date, and this is basically the index that I have here. And then I reset the index in order not to have a time series anymore. Okay, it will be like this. So we have a column of date, and the index will be replaced with just the numbers. So it will be a normal data frame from now on. And after that, we only need the adjusted close and the date. So that's why we just say that we just need these 2 columns. And then what other things we need to do is the adjusted close. This variable should be renamed because for the stocks that we have, they have also adjusted close. So if you want to merge these 2 data sets, you need to make sure that they have different column names. Okay, would be, so I just changed the adjusted close to VIX, and then the data frame would look like as the date and VIX. Okay, and now it's ready for a merge. Okay, so what we can do is that we can use pando merge command, and then in the merge command you have your left data set and your right data set, and how you want to do that. If there is a shared key that you want to merge on them, or if they have different names, which is the case here, you could say left on this key and right on that key if they have different names. And there is also a suffixes. So sometimes there is some columns that have the same name in both left and right. And that's why if you specify a suffix, for the left, it will be like the suffix like underline X. So the variable would be like the columns underline X. And for the right one, it would be the variable underline Y. Okay. So if in this case, if we didn't change the adjusted close and we remain the adjusted close here, the final merge would be adjusted close X and adjusted close Y. Okay. Okay. Now that we have Apple as a left, so we have Apple returns, I guess, from 2018 to 2020. And we have in the right VIX from 2010 to 2019. And the key that we need to merge for the Apple dataset, the column name is name date. And if you remember them, and in the for the VIX dataset, it will be date. I think I need to adjust this. It's a mistake here. Yeah. And then the question is, how you want to merge them? And just remind you, we could do it as an inner. And in the inner, it means that, so we have dates here for the left, which is Apple. It is 2018 to 2020. And for the other one, it's starting from 2010 here and starts in 2019, which is here. So the inner would be something like just 2018 to 2019, okay? And so on. You can just, if you want to have some apples in 2000 remaining here with no non-available VIX, you can do it as a left or the other way around as right. And outer is also clear. So how we do them? We say we need Apple VIX, an inner merge left on name dates. So the left date variable is name dates and the right is date. And then this is the final data set. So you can see here in the left, you have still the Apple things until here. And in the right, you have the VIX data set. So you can see that the date is the same in all of them, and it is a one-to-one merge. Okay, so there for any date here, you have only one date here. So there is a one-to-one merge. Yeah, this is how the inner works. You can have a left merge. If you have a left merge, you can see that there is some non-available things here. This is simply because our VIX data doesn't have 2020 data. Okay, so these 2020 things would be non-available here in the last two columns. And finally, something very important is a one-to-one or M-to-one merge. So if you want to make sure that your merge was correct, you can always put another another argument here, which is called validate. And it's if you say validate if it is one-to-one merge, it will go through without any problem. But if there was actually an M-to-one merge and you validated with one and one, it will be an error and this will not go through. Okay, so this is always good to have this kind of validations to make sure that you don't have an M-to-M situation. Okay, and if you get an error here, it usually means that you haven't cleaned your data enough. So you need to go back to your main data and make sure that you have unique IDs for each of the rows that you have.
So don't you often have the problem that the date format is not the same between the two data sets?
The date format, if it is like a daily thing, no, it's fine. So there is like
Must be a Python date.
Exactly. There is a Python date thing that you can just convert everything to daily or quarterly. Yeah, this is a search if you want to have the syntax for that. Okay, that's it for pandas. We have some plotting that I'm coming after the presentation. So any question here? No. So let's see. There is someone that volunteered. No, Philip, you're good. I guess it's better for you to present Git, but up to you. No, the list of topics would be a Google document that you can access with the link, and there you can just enter there and put your name there. So there is no big issue in this regard. It's on the drive, and then we'll see. Yeah, we have the track over all the chains. So if there is someone messing around with others, yeah. So good. Okay, great. Good. So let's go to EDA. And what is EDA? So you assume that you collected your data. So this is something that we will cover in 3 weeks. And you already try to do some checks if data is collected correctly. You start cleaning it, you structure it, and everything is done. Now, before you're starting your main analysis, or if you want to have a machine learning algorithm or whatever, you need to get to know your data. And this process called EDA, Exploratory Data Analysis. And it is basically just a checking of all of the variables, their summary statistics, their correlations, and so on. And the goal of this process is to have an informative descriptive analysis. This is already the answer of some of your preliminary questions. It's usually the case. And then you will get a deeper understanding of the variables in a data set. So for example, the range of the data you work, or if there is a problem with some extreme values, how you need to handle them, and so on. So sometimes in doing EDA, you spot some potential problems with the data. So for example, suddenly you see there is something not merging, or something is not cleaned enough. So you usually get into the problem that you need to go back to the data cleaning. And that's why your data cleaning codes should be very polished in a way that they should be repeatable. And then by doing EDA, you will set the path for the further steps of the analysis. So sometimes you realize that the algorithm that you wanted to have is not working on this data. You have so many extreme values. You need to change the algorithm that you have in mind, and so on. And yeah, this is the EDA overview. So let's start with what is the difference between frequency and probability. So when you have numbers, so you can always find the absolute frequency of them. So you just basically count each value. It is your absolute frequency. And if you express this as in relative to like the total observations or in a percent term, they are called relative frequency. And probability is very close to relative frequency. It is basically the likelihood of an event. It's usually between 0 and 1. It's always between 0 and 1, or you can express it in a percent term. And it's usually based on the historical relative frequencies that you see in the data. Okay, so you can see that 50% of this data set is about females. So this is the probability of having a female in the next observation, so on. Probability is not exactly the relative frequency, in a way that there are types of frequency probabilities that they are called subjective probabilities. So for example, for some things that people have different opinions, and you cannot just say it is like, it's not based on the historical view actually. And for example, the probability of next year crisis, I would say 10%, you may say 50%, and so on. Yeah.
Probability could also be the outcome of a machine learning algorithm or any kind of model.
Yeah,
which again is subjective.
Yeah, exactly. So how you basically, yeah, this is when it is not purely on the historical values, they are not they are subjective probabilities, and they are not yeah, and everyone can have different opinion about those kind of probabilities. And then from relative frequencies, we can always find the distribution. And the distribution is basically the frequency of each of these values in the data that you have. Okay. It's usually the first step of the EDA to plot the distribution of important variables. And for categorical variables, you usually present them in a histograms. And histograms could be vertical or horizontal bars. And you could also if you have like multi-dimensional data set, you can stack them or just make a differentiation between two type of them, male, female things or something like that. Okay. There's also density plots. So I'm just coming to them here. So that you can just present the density of the data or the distribution of the data over one axis, or if you have like, if you want to have a 2D plot, so you have a first variable and second variable, it gives you already a kind of a correlation. So if there is a correlation here, and then you can see like the density of each of two variables here. And the things that you need to note when you present the distribution of a variable, you need to check so how many tails it has, if there is just one center or two center to the distribution, if the data is symmetric or if it is skewed toward the right or left. If there are some extreme values, for example, if there were some extreme values, there is like one dot here, and then this won't be a very nice plot anymore. And that's why it's really easy to notice if there is a problem with the data when you just first make a distribution plot. And you can always check for a variable if it is a normally distributed or if it is log normally distributed, so and so on. Okay. Okay, let's talk about the extreme values. So the extreme values, they are usually very large numbers or small numbers that are usually rare. So it's not a common thing in the data. So if you have a 1,000 observation and 2 or 3 of them have a huge number, they are called extreme values. And some people call it outliers, but outliers is not necessarily a good word to describe them, because these kind of variables could be due to error. So for example, you have a data set based on how big are the assets of the company. And if it is on $1 trillion or $1 billion, there was like some of them that was not in the $1 trillion, it was like a normal USD dollar. And that's why you see that there is like a huge number suddenly somewhere. And then this is just simply an error that you need to fix this, okay? But it could be that they are part of the data that you have, okay? So some data have extreme values by nature, okay? So if you want to have the returns on distressed firms, this could be very volatile. That's why it's normal to see some extreme values. Or if you look at the people's monthly medical expenditures, that could be just a spike somewhere. Also the salaries and so on. Okay, so some data sets have extreme values in nature. And how to handle these extreme values? If there are errors, you can just simply correct it. Or if you don't have the correct number for that, you just convert them to a missing observation. Okay, it's easy. But if it is part of your nature, the nature of your data set, you could do two things. So you could just reframe the analysis that you have. So you say that I don't want to focus on big firms. I want to have small and medium-sized companies analysis. You just censor them in a way that you just trim after a bigger number. So say if it is more than 100 million total assets, I don't want to cover them on my analysis. So they're calling censorings. The other way is to call it, people call it vinsorizing. So basically what you do, you just replace the values after a certain percentile to the maximum value you have. And in Python, you can use SciPy and import vinsorize there. So basically you give a list of numbers and you say the limits should be 5th percentile from the lower this part and the 50th percentile from the higher part. So if everything out of this range, please just replace it with the 95th percentile or the 5th percentile. So in this case, for example, 101 would be replaced with the, or okay, sorry. So this is the highest number, maybe out of this range, and then this it will be automatically replaced by this highest before number, 101. Yeah, it depends. Sometimes Winstricing is fine, and sometimes you just need to just delete those numbers. Any question here? Okay. Okay, we go to visualization, but let's see if there's any question in chat. No. Okay, so let's talk about visualization. First of all, you need to have a purpose for doing the visualization. So usually you want to have a message that this graph is better to convey. And this is usually the case because graphs are better ways to just communicate. And then there are many cases. For example, you want to have the conclusion of an analysis in a graph, or you want to just show an important feature of a data or one columns and so on. The other thing is that your visualizations should be focused on one message. So if you have one graph, it should be about one message that you want to convey with this graph, or if you have two graphs next to each other, they should just complement themselves. So for example, you can have a histogram of a variables and then a box plot next to it to just show the distribution of a variable. You cannot have like millions of things in one graph. And you always need to check your audience to whom you're going to present your visualizations. And on that, there is a rule of thumb that depends how much control you have on your audience. So if you're, for example, presenting a set of slides, you don't need to have lots of details on your slides. So if you talk with consultants, usually they call just one simple word there. Don't fill your presentations with many things. On the other hand, if you don't have any control over the audience, so the extreme case would be just these peer review journals that we submit the works. So when you don't have any control on your audience, you need to fill as much as the details you need, because those guys could just start thinking about something different, and then they don't get your message at all at the end. Okay, and there's always a point that you need to make sure that if you want to have like a slide that could be shared later. So you need to have like a combination of both somehow. So this graph is taken from a book that is Storytelling with Data. And I'm going to spend the whole next session on this book. This is a great book, how you should avoid bad graphs. And there are bad graphs everywhere. So we will focus more on visualization next week. And yeah. The other thing that you need to have on your EDA is the summary statistics. I think you all aware of all these measures that we have here. So we have several types of statistics, and statistic is a number representing a feature of your data. Okay, so if you want to talk about the central value, it means that you need to talk about mean or average, median or mode. If you want to show the range of or spread of your data, you could start with range. So simply the difference between the maximum and minimum. Or if your data is very has lots of extreme value, it's better to show the difference between interquartile range. So like the top 75th quartile and 25th quartiles usually. You can talk about variance and standard deviations as well to show the spread of your data. Also, skewness sometimes is important to show in your summary statistics. There are clever ways to show the summary statistics with graphs. So in the left, you can see the box plot. So the box plot is basically just a line with one adjacent line for the 25th quartile. It's like one whiskers, they call whiskers, so it's like the cat's mustache. So the whiskers for 25th quartile and the whisker for the 75th quartile. Usually you show the median here, and there's a box around them. And there are an upper and lower adjustment values, and they are usually 1.5 times this range. And so there are like many packages that does this automatically for you. And then there are some values that would be showing by some dots if they are out of this line, this range. Okay. There's also a more clever way to show it, and we call it violin plots. So basically, you will have a distribution of the same variable. So in addition to the box plot, you just show the distribution, and this is a symmetric thing. So this is basically one distribution, just mirrored twice. There are even more creative violin plots that you can have. Just, for example, you have these variables, and then you got the distribution for the male and females and so on. So you can have non-symmetrics as well. Okay, question? Good. Okay, and finally, let's review the most important parts of the EDA. Is that first you focus on the most important variables, and you go back and look if there is a subsequent analysis suggests to do, and then you you have qualitative variables that make sense to have the relative frequencies of them. For quantitative variables, histograms are great to see the distribution. If you want to check the extreme values, you start with some summary statistics and plotting them, and also you can look at some correlations. There are correlation metrics that I will show you in a moment. And yeah, so yeah, usually if there is, you'll get a sense that, for example, you need to do your analysis in a group or list them. You just do a time series analysis in the middle or something like that. EDA, there is like not a perfect recipe for doing EDA, but there are nice EDAs that you can look at the internet, and then you can try to be more professional. So there are 2 homework assignments that I had already in your in the website, so you can look at them. They're already solved. You just need to go through them and see how people do it in a real world. Okay, so this is what I had on EDAs. It's great that we have enough time for Matplotly. Okay, so first let me start with some plotting in pandas, because pandas offer you usually a very handy kind of plottings. So if you have a data frame that you want to do some plots on them, you can use the data frame.plot method, and it has a nice documentation here, and it is based on Matplotly. So if you know Matplotly, you will be you can start easier working with them. So for example, if you want to have a histogram of the returns of Google, okay? So first we define Google. So we get the subset of Google returns from the main data frame that we have. And then we can just say, yeah, we need to plot, and the type of plot should be histogram. So there are many ways to do that. There is line, bar, horizontal bars, histogram, box plots, kernel density estimations, density, and area, pie, scatter, and hex bin plots. So you basically say, I want an histogram of the returns. You can see that. You can just add 2 things in the same graph. So you can say that, yeah, I need also to plot the kernel density estimation, and I want to pass it on the secondary y. So that's why you can just compare 2 things. So this is your histogram, and this is the distribution that is fitted to this data. And you can also have some time series plots. For example, you can say that, yeah, I want to make a time series. The way you make a time series in pandas is to just set index with some date variables. It will be a time series for you, and then I just want to plot this, and then it will be the plot that you want. Okay.
But wasn't the date already in the data?
It was there. So the name of the column was named date. And then you
Okay.
just set the index as name date. So the index would be some dates. It would not be a number anymore. Yeah. And then basically you just plot it. Okay. So now let's go to the more powerful Matplotly. Okay. So the way you usually use Matplotly is you call, so you have a data, you call that Matplotly plot your data, X, Y variables. And then in the next lines, you can add some aesthetics to that. So for example, I need the secondary y-axis to be like that. The X should be presented like this and so on. So you have lots of codes in the middle. And finally, you can write Matplotly show, and then it will show the final graph. And there are a gallery of Matplotlibs, and you can see how wide is the usage of Matplotly. So you can see all of these graphs that are here. And if you're interested to any of them, for example, this, you can see the code is already there to just produce this Matplotly thing. And you can just play around with them to your own data sets, usually very easy and straightforward. So that's the main thing that you need from this lecture. Okay, it's all there.
Is that easy to Google?
I have the link there, but yeah, I think it's just Matplotly gallery. I think, but it's Matplotly, right? Yeah, this is like this. Yeah. Good. Okay, so Matplotly is the backbone of many other data visualization tools that you will have. So for example, this pandas visualization that I just showed you is based on Matplotly. There's also a PyPlot API. This is part of Matplotly that is used to show most of the things that you want to work with them normally. And it is based on MATLAB. So if you are a MATLAB user, you should be very familiar with this PyPlot that I'm teaching today. And then there is Plotly. The good thing about Plotly is that they offer some interactive plots. So in a browser, you can just click on them and see specific data that was shown here and so on. So this is, if you want to show it in a Jupyter notebook, I think Plotly is the best. If you are a heavy R user, there is a ggplot, which is basically R's ggplot2. And there's also Seaborn, which is very nice. And next week, we will have the presentation on it. Okay, so what we do today is just Matplotly PyPlot. And it is based on chapter 7 of the book. If there is some of you have problem with downloading this chapters from OLAT, just come to me after the class. I didn't find any problem with several pieces that I tried. So there are some people in Piazza that couldn't open it. Yeah, and the PyPlot tutorial is also available here. It's the official one, so you can basically see everything in a very nicely documented way. Okay, so how we started? So we say import Matplotlib as MPL, and then because we worked with PyPlot, we also import the Matplotlib PyPlot as PLT. Okay, and importantly, you need to say what kind of styles your graph want to have. You can look at another gallery here.
Just a practical thing. Sometimes when I try out things, I forgot to import the right thing. Is there just a long list, basically, that you couldn't follow everything, and that you are always on the same side?
No, there is like, you always need something, and that's why you need to import that. So that's, you always need to think what you want, which libraries you want to work, and then you need to all import everything in the beginning always. But I mean, for myself, I have a big list of everything, and I always start with them, and then suddenly see there's nothing.
But you always import only the ones that you use.
In the class, yes, but in the real world,
Okay,
no, I have a long list of everything, so I just import all of them. Yeah. So what I'm doing today, I want to use this style of graphing. You can just select whatever you want. There are other ways to show them, but yeah. So there's also the Seaborn style that you can just have the Seaborn style of graphs like this. The other way. And today I'm presenting this basically. So the type is ggplot, I guess. And then I just say, yeah, for pyplot, please use this ggplot style. And everything would be in ggplot style. And then I just want to have this kind of font, serif font. It's up to you. There's also some defaults if you don't specify this. And then we have a Matplotly inline, which is, I guess, only for Jupyter notebooks. So if you have this, it means that you don't need to plot it anymore. So this third thing, you don't need to have this show anymore, and it will be inline. So when you click on the run here, it will be just showing to you in the next cell. Okay, now let's start with a simple plot. So you have just some x and y's. So here we have some x, 1, 2, 3, and some y's, 10, 11, 12. And I just want to plot them in a line. Okay, so basically, this is how you see it. And the style is ggplot. So if you don't have ggplot, there are like different backgrounds, the different fonts, and so on. Okay. This was the simplest thing you could do. You could start just drawing some mathematical functions like sinus, and so that's why I just import NumPy to create a line space and math to have a pi number. So because it's a sinus plot, so I just start a line space from -2p to 2p, and I need 100 points in the middle. Okay, this is my x, and for y, I just need the sinus of each of these x's. And now I just want to plot x and y based on that. Will be this. So starting from -2p to 2p. Okay. You can just use x to plot this. The difference would be that if you do this, then the index would be your x. Okay, so it starts from 0 to 100. So you have x 100x. That's why you have 100 observation here, and this is the y that is plotted here. So now you can make it more beautiful, the same graph. So for example, you want to change the axis length or what the axis looks like. You can just first like make the plot without any axis, just like this. Okay. Or you can say, for example, I want to limit the axis to some x min and x max and y min and y max. So I just want to, yeah.
If you use plot show, for example, the figure is the categories. So when you use plot axis off, for example, it displays it just automatically by using it. It's plot on afterwards, or could you then also, after you turn off the axis, also change that?
And the thing is, when you use PLT show, it shows whatever is recorded onto the figure. So usually it started with a blank figure, and you add some graphs to that, and then when you say plot show, then it shows you the final thing. In the Jupyter Notebook, it is straightforward because after a cell, you get the picture you just created in the previous cell. But if you don't have a Jupyter Notebook, you have like a normal thing, you need to say when to show this figure and then just create a new figure after that.
Okay. So one thing I noticed that once you use show, for example, if you say figure afterwards, then we wouldn't have anything because it showed like the whole output was the show and then it's gone. So the same, you have the PLT axis off, for example, then it showed without X and Y axis. Could you do that and then change another thing to change color like afterwards?
Yeah, it's on the memory still here. Yeah, so basically it was on the memory. So, and now I can just, let me try it. So it's now gone. So you don't have anything again. So that's why you need to plot it again and say, do this stuff and then show it.
So you couldn't, do multiple things after each other every time.
Yeah, every time. So each cell has one plot. So you can start a plot, add some other plots if you want, but when you show it, it's all there. Next slide, there is no plot anymore. So you need to create it again. Yeah. You can just import this plot to one object and say this object, and then you use this object for later on. You can do that. I'll show you in a moment. But otherwise, no. After a selected. Okay, so this is another way to just set the limit. So this is like all the things you can do with the axis. Yeah. So one nice feature that you can have is if you want to have LaTeX type. So if you want to have mathematics type in your x-axis, for example, instead of numbers, you want to start with pi. And so you can just say, I need 3 numbers in the x-axis. So -2 pi, 0, and 2 pi. And then the way to show them is like to have the LaTeX kind of doing that. So you can see here, -2p. And the pi is basically like the pi LaTeX formula for that. And you can always see list of everything you can work with LaTeX.
Is it actually importing some kind of LaTeX?
No, it's like it's included there. You don't need to import anything. Yeah, so this is exactly, you can have everything there and just use the LaTeX formula for that. Okay. You can have more aesthetics. So you can basically control the color of your lines. You could control the style of your lines and so on. For example, I just want to, okay, let me start a new graph. So here I want to have a bigger graph. That's why I want to have a figure of size 11:5. So this is just a ratio basically. And then you say, I want this plot with this style. And this style means triangles right marker. And I just show you what does this mean. So you have some triangles here. It will be like that. So you can just, instead of that, you have some dots. You can just have it with dots. And there are like millions of ways. So this is the sum of them here, you can see. And also the color, you can just say, I want it to blue. I think you can just pass it right away. Yeah, and so on. So you can say blue dot, I guess, then it would be blue dots and so on. Okay, Flip raised the hand.
Yeah, can you hear me?
Can you unmute and I can repeat the question?
Yeah, I just wanted to add a remark that it actually helps to think about Matplotlib like a canvas. So you basically start with an empty picture and then
I don't hear. Oh, okay. Sorry, I don't hear you because I muted myself as well. Okay.
Okay, yeah. I just wanted to add that it actually helps to think about Matplotlib like sort of a canvas. So you start with an empty canvas and then you add everything you want, like axis, legend, the type of plot that you want. And then in the end, you show it. And you can just basically, with the figure, you define your X and Y axis. And that's basically your plot, and you can add elements anywhere
Exactly. Yeah.
on your canvas. Yeah.
Sure. Yeah. This is like basically how Matplotlib works. So it's basically a canvas that you just start your blank figure, and then you just add things. So you can add many plots. So you can just have like here, for example, you have two plots here. You can just have y to the power of 2 maybe. Two plots, and then you can just have everything written. Like I don't know if I can. Yeah, but anyway. Okay. So basically, you can have many figures, and if you look at the Matplotlib gallery, if you go to some of them, you can see that there was actually created this space. So there was like one thing here, and then it created another thing. That's why you can always create very nice figures. There was like this can basically create. You can have many elements and just calculate every time and put something there and so on. Yeah. Okay. And then usually have like controls over the labels. So in this label, please put X here, and then in the label sinus of X, and then you have a title also here, and so on. Okay, so you can also have multiple plots. So this is exactly what I did already. So I just don't want to. If you want to have sinus and so the cosine of this, then you can have both of them together and so on. Okay, so and usually when you have multiple plots on one figure, you can just have some legends to make the difference between them. So you can say that I want, so this red one is the sine and the other one is the cosine. And then you can say, please plot the legend as well in location 0. Location 0 is here. You can see the different locations that are available to you. If you want to have it on center, you can just 10 and so on. Okay. It's also possible to literally plot it. So you can say that go to the X and Y of that and put this stuff there and so on. Everything is possible. Yeah. Then the other way to do this is to use subplots. And by subplots, you can say I have one plot here and the second plot there and third plot there and so on. So what you do, so there's two ways to do that. So if you have a shared X, so it was the case here. So you have one X for both of these two plots. So you can always create a figure, and the first figure would be, and you should just say that we have a twin X, so they have the shared X somehow. So here I create another y3, which is an exponential of X. Which is a very big number at the end. So that's why I need to have separate y's. But if I don't separate them, then I basically don't see the red again. So that's why I need to separate the y for exponential and the sine. Okay, so the way I can do this is to say, okay, plot first the sine, and then create the second figure with the same X, with the twin X, and just plot the other one. This is basically how it works. And Yeah, so there's also easier ways that people usually do is to have subplots separately. So you can say, I need a subplot of 2 in 2. So you have 2 columns and 2 rows. And in the first place, so the upper left, you plot the sign, and in the upper right, so 2, 2, and the second, and 2, 2, 3 is the like the third one, which is down. You plot the exponential one, and then you can create several subplots, and so on. Yeah. Okay, so let's see how we can create histograms. I just don't know what was this link here. Yeah, this is like the millions of graphs that you can create here. Okay, everything is explained very nicely here, but just important thing is the histogram that you basically, I just draw some random numbers. So I created 2 sets of random numbers to just compare them. So for the first set, I just want to have a histogram with 30 beans. So it will be like this. You can just play around with the beans to find the optimal optimal beans that you want to display your data. And then you can have 2. So as I said, we have 2 lists of normals, so we can display both of them. So like one of them is the first distribution, the second is another distribution. There's many ways to do that. You can stack them over each other. So it will be like this. So it's up to you how you want to plot them. And you can also have the scatter plots. And if you want to have, it's usually nice to have dots because otherwise it will be like 2 big figures, so you cannot solve them easily. And that's it basically. So there, yeah, always don't forget to check the gallery before you want to visualize something. You always get good idea of which of these graphs are the best way for you to handle things.
Also, in academics, people prefer some plots over the other. Yeah? They are usually without color and clear style guidelines. Is there any way to slip for this? Or?
So for academic things, the problem is that you want to make sure if you print something on a black and white, it's readable. So it depends on your audience, as I said. So if you want a black and white style, there is a style just for black and white. So you have the grayscale thing. It will make sure that everything is readable in a kind of black and white print version. Very good question. Else? Okay. Good. So Plotly is a big project. So we will have next week someone who is presenting this. But I want to just show you a nice library. A subset of the Plotly is Plotly Express. And it works usually in a way that, so you need to first import Plotly Express as PX. And you just say, I want to PX scatter line area or whatever, PX that, and then you pass your data frame. So it's a Panda data frame. And then you say, I want X to be this and Y to be that, and then just click show. Okay. And the Plotly itself offers a very nice documentation for everyone. So okay, so if you, for example, so the basic plots are scatter line, area, bar, funnel, timeline. So for example, if you want to see the scatter, you can see basically for any language. It's also nice. So for all of them, there is a presentation. So you can just import the Plotly Express, and then you say px scatter with this x and this y, and then it shows to you. The good thing is it's interactive. So if you do it in a Jupyter notebook, you can just fly over all of these observations. And if it's the line, there are different data sets. You can always check them manually with your mouse. And you can always zoom, for example, to a certain part and take a screenshot for yourself. And so many things that are available here. Yeah. So for example, if you're interested into this part here, you can just download the PNG file as a screenshot of this graph. And you can, yeah, as I said, you can just pass a data frame to that and say, I need this column to be X and this column to be Y, and so on. So there is, you can basically separate based on kinds. So for example, if you have, this is an, Iris is a very famous data set. So it's like basically some flowers, different species of a flower with different size of length, leaves and so on. And you can see, so you can separate based on the type of species that you have, and then just plot the sepal width and the sepal length. And then you can just see, for example, for each of these numbers, for each of these observations, you can just see what was the data there, the data frame that was there. And it's really nice. You can have a legend of, and yeah, and so on.
So just copy and paste these 2 lines of code.
Exactly.
And put it to Kaggle. I can't find the code because I don't have the data set, don't I?
You need to for the the good thing is that Plotly Express has this data itself. So basically, if you want to have them, yeah, so you can just play around very easily. Because yeah, they're part of the PX is that there's some data sets. So there are several data sets that you can try with them. Yeah. Like many of these graphs was the first time for me to solve them as well. So that's why. So yeah, I think it makes sense for you to just go through all of them. So also the violin plots that I just showed you. So there are many ways to show violin plots. So you can just have a violin plot with some data next to each other, and like you can separate them. You can have several data on one graph. This was here, I guess. Yeah, so you can have non-symmetric violin plots as well. Yeah, so basically whatever shape that comes to your mind, you could find them there.
So if you apply this, you copy and paste and replace the data set.
Yeah, exactly. This is your graph then. Yeah, basically. This is, yeah, very straightforward. Yeah, there's also like, yeah, for some of the graphs, you need to have Plotly Go. So, but I don't want to introduce all of them because next week we will have a better overview, hopefully. And very nice. Good. Yeah, I'm done with the presentation today. So there's just one thing that I want to mention is the homework that you need to do. There is this notebook that basically tries to walk you through an EDA. So you have this data set on older people. And then there are some questions that you need to code them. So how many men and women are presented in the data set and so on. Okay. I would try them myself and compare the solution that is available here. So this is already solved here with everything you need. Okay. Then there is another one that was actually a winner of a competition. So from time to time, there is a competition in Kaggle that you can compete with other data scientists. So this guy was is sharing here the EDA that he did for this big competition here. Okay, so for the housing price, at the end they do some machine learning things. You don't need that, so it's just the EDA part that you need. So this is like what we do here, and then so we clean it again, and then we start doing some modeling. But yeah, it is like, this is the way that data scientists present themselves. So like they usually have a blog with all their codes or a GitHub page that they share what they did. So this is like how future employees can look at your profiles and get be impressed. Yeah. So, and at the end, this is like I looked at this. I'm sure that you can do it more professionally than this even. So feel free to work around this. It includes lots of seaborne plots. I hope should be fine to just look at them, how seaborns work. But yeah, next week we will also cover seaborn. Okay, that's it from my side. I hope, yeah, there is no question in the chat. And yeah, we can maybe finish it. Okay, thanks a lot and see you next week. Yeah, bye-bye.